Great. Thanks again, Ryan, for organizing. So today I'm going to speak about building iOS apps with confidence, and essentially what makes Slack a good place to work, and give you some context around that. So first of all, hi, my name is Doug. I'm a software engineer here on the mobile developer experience team. I've been with like you just mentioned, I've been with the company for just over 2 years. And today I'm just kind of go back and talk about the mobile developer, what it means to be a part of the mobile developer experience team, some of the early projects that we took on when the team was first formed, and really, how we use metrics day to day, and how we use metrics to drive some of the projects that we work on. So way back when, back in 2016, Cal, our CTO, once said, we want to make Slack the best place in the world to make software. We're not quite there yet, but essentially the mobile developer experience team was founded to kind of put that into action. And just to give you a little background on what we're dealing with, currently we have about over 70 mobile developers, and this is both across iOS and Android. We have anywhere from over 50 pull requests per week across both platforms. And we have about over 30 CI jobs to support that effort to release and build every single day. So like I said, I'm just going to take a step back and rewind a couple of years ago and kind of talk about where this team came from. So originally, I was a part of the iOS Foundations team, and me and a few other developers kind of worked on tooling as far as like testing frameworks and whatnot to kind of support our iOS developers. And we had the same set of same number of developers on the Android side doing a very similar role. And we thought it was a great idea to kind of join forces and see what kind of tools and tooling that we can do across both platforms, and kind of share our ideas. And we came up with an idea, a goal, a guiding principle, and it's to build tools and systems that empower mobile developers to ship code with confidence while enjoying a pleasant and productive engineering experience. There's a lot there, but really when it comes down to it, when we first embarked upon this, we really didn't know what that meant, right? We had our build systems were a mishmash of like build scripts and Jenkins, and we really didn't know what was going on, right? And for example, back then, Jenkins would just reboot and crash out of nowhere for no reason, and nobody really understood why, right? Our build scripts were spread across multiple repos, and they called Xcode directly. And they were written and iterated over time by numerous developers when there was a need for such a thing, but nobody really kind of took a holistic approach as to how these systems should work and how we can best iterate on them. And back then, I would say a lot of our mobile QA was done manually by our QA teams, right? So that's not exactly very scalable. So we're kind of looking at ways to kind of improve our build systems and testing. So as usual, management comes down and says, let's write tests. Let's automate everything, right? Let's go, we need to write automated tests. Let's figure out how to do that, right? And back then, we actually came up with this idea of Test Week. So we stopped development across both platforms, and we told our developers, hey, let's go write some automated tests, and let's see what happens. Guess what? That didn't work out too well, right? We didn't have the tooling, we didn't have the framework to support it. We really didn't know, like, as far as the developers are concerned, they really didn't have a good starting point. So the team was founded essentially to kind of help solve these problems, right? And can't give a testing presentation without the testing pyramid. Our developers spend time writing unit tests. The developer experience team, we're looking into different frameworks. So for example, we were trying to determine which testing framework should we use. Should we use Earl Grey? Should we use KIF? And back then, we actually landed on KIF to do our integration testing, and we started building out tooling for end-to-end testing, and we were trying to decide like what kind of performance testing we could do. Should we be running on simulators? Should we be running on physical devices? And the moment we had all these tests, the first thing that everybody wanted to do was start blocking PRs against them. And guess what? Things just started failing, right? Like, again, we were running these tests. We were trying to block PRs, and every single failure we got, developers were getting frustrated because they didn't really understand, and we didn't really understand like what was failing. Why were our PRs being blocked? Developers just kept mashing the rebuild button to get their PRs through. And like I said, we didn't really understand what was going on. So the first thing that we did was change from scripted jobs to declarative pipelines. Now that helped us tremendously. Using declarative pipelines allowed us to iterate on our jobs, allowed us to do updates, environmental updates like Xcode updates, Python version updates without actually breaking prod jobs, which we did a lot at the time. And we also adopted a tool called Fastlane. So what Fastlane is an automation framework that takes care of the building, the device, certificate signing, and even App Store uploads. So moving to Fastlane allowed us to really kind of dig into our build scripts and understand what was going on, understand what was written over the last couple of years, and kind of clean them up and consolidate them into a single place. And that, in combination with Jenkins pipeline, really allowed us to kind of iterate on our CI systems without taking down the entire system. So beyond that, we realized we needed to gather metrics, right? We wanted to really dig into why these jobs were failing. So we wanted to understand how long these jobs were taking to run, how many PRs we were pushing, what kind of capacity we needed in our CI systems, why jobs were failing, why jobs were timing out, and so we started collecting metrics on that data. We created a very simple script that we applied to every single CI job, and we just started uploading all the stats, right? Collecting as much data as possible. And really, the purpose of this was to kind of address three different areas, right? We wanted to understand the pre-merge scenarios. So anything that, all the checks that we were doing going into a PR, post-merge checks, like how long they were taking, why they were failing, and as well as the local local developer environments. So to address the first part of that, the pre-merge, we came up with a metric called time to mergeable, or TTM. This metric is essentially the time it takes for all of our PR checks to run from the moment a developer creates a PR till you're able to click that merge button, assuming, of course, a review has taken place. So this is kind of a best case scenario, right? And the great thing about that is it forced us to kind of understand, all the checks that we were doing and parallelize them as much as possible. Originally, one of the things that we thought we could do was build all the test artifacts once, save them to S3, and then test them across all the build nodes. Our hypothesis was like it's much easier it would be much faster to just run the tests. Turns out that wasn't the case. Because the build artifacts were so big, it took us just as long to upload them to S3 and download them on the test nodes that we might as well have just built them on the machines to begin with. And like I said, we created dashboards to kind of actively monitor this to make sure that we weren't, any change that we were doing was making a positive improvement to TTM, and we weren't degrading the experience. We also tracked master builds, right? So the time it took post-merge, right? How long did these builds take to run? We ran the same checks pre-merge and post-merge. And having this metric allowed us to do testing and understand why builds were taking longer. So for those of you in the iOS development world, over the last couple of years, with every version of Xcode, there was an incremental, builds would take longer and longer, right? This, kind of gave us insight into why that was happening. One interesting experiment that we discovered recently was the fact that switching over to Catalina had a dramatic increase on our build times. So as such, we've decided to hold off switching to Catalina on our CI nodes, and we've asked local developers to do the same thing. So the third piece, like I mentioned, was instrumenting local developer build time, right? So as we were tracking local development builds, as you can see, we were at, at one point, we were running right around 100 milliseconds for incremental builds. And having these dashboards and having this data allowed us to catch an incident back in October. So, we were looking at these metrics, and for whatever reason, our local build times had doubled. Going back into the PRs that day, nothing stood out to me as the cause for this. Like, we didn't introduce any new frameworks. There wasn't any major code changes. So it forced us to kind of look more environmentally. And guess what? Our security team had upgraded our antivirus tools that day, on that particular day. And the compilation process being very processor and IO intensive, works in direct conflict with our antivirus tools. So because of this, we were actually able to spin up a project where we whitelist a local folder on all of our iOS developers and prevent that scan from happening and bring these numbers back down. So aside from build times, one of the other metrics that we were tracking was master build stability. So this is essentially how often our master build passes and fails, right? And like I mentioned, we run the same checks pre-merge and post-merge. So what master build stability kind of tells us is it's a proxy into how our tests are actually behaving, right? And in the ideal case, all of our tests would pass post-merge and everything would be at 100%. But seeing something like this really tells us, well, guess what? We have flaky tests in our system, right? Having these dashboards kind of forced us to kind of investigate, well, why are these tests failing? One of the hypotheses that we originally had was, like I mentioned, we were using KIF as a testing framework, and all of our developers were thinking, well, if we switch to Earl Grey, all of our problems would be solved. Guess what? The Earl Grey or KIF wasn't the root cause of our flakiness, right? So when we investigated this, it really came down to two things. First of which was stale state. So stale state refers to the fact when we run a test, sometimes a developer would set a flag or change a localization variable or store something in memory that had adverse effects to our downstream tests. So knowing that, we were able to spin up a project where we kind of isolated these things and mitigated that. The second biggest problem that we noticed was the fact that we have a multi-threaded application, and writing multi-threaded tests are difficult, right? So we spun up a second effort to kind of figure out, what's the best way to kind of mitigate these issues. And that's an investigation that's still kind of ongoing. So, but the main thing we wanted to do was, we knew flaky tests were in the system, but we really didn't want to slow down developers, right? So we were trying to figure out what's the best way to do that. And, we kind of came about that we should retry these flaky tests. So we adopted a tool called Blue Pill. Blue Pill was originally developed by LinkedIn, and it was a tool that was built so that they could run parallel simulator testing on a single node. And this came out way before Xcode had that functionality. But in addition to having that functionality, what it did have is the ability to retry tests, right? So we embarked upon a project to integrate Blue Pill in our systems, and the very first week that we launched Blue Pill, we had a 99% build stability, right? And the single build failure that we had that week actually had nothing to do with flaky tests. So, this allowed us to kind of put a little more confidence into the build system, into our tests, and kind of got our developers over the hump of just mashing that rebuild button every single time their PR check failed. And some people might think that we're kind of putting these problems under the rug and kind of ignoring the fact that we have flaky tests. I wouldn't recommend that you implement such a system without actually tracking them. So we created another dashboard to track every single time one of these tests failed in CI, and we're able to actively monitor anytime a flaky test enters the system, or any other reason for that we will see an increase in failures. I went over a lot of kind of different metrics, a lot of different dashboards that we have, and that's just kind of a small subset of all the data that we collect. And as a team, we monitor these stats every single, in our team meeting, we have a devoted section where we monitor these stats every single day. And just to kind of try and catch some of those regressions that we see, trying to catch increases in TTM, or that weird, antivirus issue that kind of came about. And, fundamentally, what it comes down to it is this is just a basis, a starting point, right? So, this is going back. This is what I mean, where we've kind of made Slack a good place to develop iOS. Without these tools, we wouldn't have the foundation of which to kind of embark on more challenging problems that we're going to look through ahead. And that's all I have for today. Thank you, guys. Do we have? I can take a few questions. Yep.
How do you guys handle flakiness? And when, say, for example, a test gets way too flaky over the time course of period?
So we'll see that pop up in our dashboard. So the first thing that we do is proactively reach out to the developer to understand, what's causing the flakiness. And we ask them to kind of, tackle it head on. If it's pretty bad and they don't have a solution for it immediately, we will disable it. But having those dashboards actually just gives us that insight to know, when these things happen. Yep.
Does every test have an owner associated with it? You said you had.
That's actually an ongoing project that we have, where we're actively trying to map test owners and figure out where, who to go to. Right now, it's a kind of a laborious process, just kind of looking and get history essentially. But we're trying to figure out a way to best do that with tooling. Yep.
You can go ahead. What tools do you guys use to generate these metrics you mentioned?
A lot of them are kind of in-house. So, for example, the flaky test, like Blue Pill generates a report, right? And we'll just parse the report and upload them to our database. Some of the graphs and charting that I showed is a reporting system that we have built in-house. They're pretty simple, right? It's just gather the data and plot a graph, right? So there's not a lot of smarts to this right now, but actually one of the projects that we're embarking on is tracing. So we're going to start trying to trace more of our jobs and build processes to understand, at a more granular level, where these things are happening. Yep.
So are there any entry points that could break tests that don't necessarily go through source control? Like an example would be experiment pushes.
We have feature flags and whatnot. So for our unit testing and functional testing, everything's essentially mocked out. Our end-to-end tests do actually hit the network, but it's a more kind of controlled QA environment. Oh, one more question.
Well, how do you go about controlling that environment? You said a static snapshot of the features, or
the end-to-end environment.
End-to-end.
There isn't a great way, right? That QA environment changes as our back-end team rolls out changes. So, that's an ongoing battle.
Okay.
Are all the tasks 100% automated, or you still have anything?
No, we're working towards automating our entire regression suite. This is I'm sure like many people, this is kind of an ongoing process. Our stance right now is actually to not add any more manual testing. So, we're asking, as a part of that kind of mapping process, we're trying to understand, what manual tests can we automate, and, who owns them. Yep.
Do you store Android and iOS tests together in one framework?
They're stored. The iOS and Android are in separate repos, but it's just one giant repo, and the tests are with them.
But you mean one repo, two folders?
Sorry, iOS has its own repo. Android has its own repo.
Okay.
Yeah.
So then what's the one giant repo?
Well, they're individual mono repos essentially. Individual platform repos.
All right,
Sorry,
so two
yeah.
Git.
Yes.
All right, cool.
Yes. Well, actually, we have a third one for all of our testing resources.
Wait, you mean the infra or the actual test for the iOS?
For some of the parsing logic, all that kind of stuff. Yeah. Yes.
Can you guys speak to what kind of infrastructure you run the tests on?
Sure. For iOS, all of our tests are run in simulator through a third-party provider. For Android, they're run in both simulator and we have some physical device testing, and that's done in Firebase Test Lab.
Are you doing any edge case testing, like network throttling or anything like that? And how
Mm,
has it affected flaky tests?
We haven't embarked that far yet.
Okay.
Yeah. Yes.
Could you please share your personal experience if you worked with like any iOS simulators? Like, which would you prefer?
Simulator it really depends. So we use simulators today for a lot of our, like I said, all of our unit functional and end-to-end tests. The few cases where we do use physical device testing is for performance. Yes. Yes, the XCUI test runs our end-to-end testing. All right, great.